1826 local time. Southern coast of Keshem Island. An Iranian missile crew is finishing a firing solution on an oil tanker crossing the strait, the same maneuver that set 2 ships ablaze in these waters last week. What the crew doesn't know, 2 American destroyers, southeast of the strait, already have them locked. They're about to find out what a 90-second answer looks like. The first salvo. The forward deck of the lead destroyer erupts. A solid rocket booster punches the first Tomahawk straight up through its own exhaust. 4 seconds later, the handoff. The booster falls away, wings snap out of the fuselage, a scoop drops beneath the belly, and the missile settles low over the swells. Behind it, a second is already climbing. A third breaks free before the smoke clears. 2 miles off the beam, the second destroyer empties her own cells inside the same minute. This is the Mark 41 vertical launching system. 96 cells beneath the deck, arranged in modules of 8 around a single armored exhaust chimney. Engineers call it a hot launch. The rocket motor ignites inside the ship, and the hull swallows that exhaust at point-blank range without scorching the deck. 12 missiles. 90 seconds. Both ships turn and open distance. Nobody on board celebrates. The receipt is already printing. The other clock. 174 miles northwest, under camouflage netting on a coastal ridge, another crew is deep in its own countdown. Their battery, a Chinese-derived anti-ship system, has the same tanker in its sights. Course, speed, a firing solution moments from complete. The request for launch clearance is already climbing the chain toward naval headquarters. Out on the water, 40,000 tons of crude steams into the strait at 12 knots, oblivious. 2 clocks are now running on the same patch of ocean. One crew is racing a bureaucratic signature. The other hasn't even cleared the horizon yet. The physics of hiding. The missiles now inbound fly on 2 engines. A rocket booster provides an enormous initial shove, finished in about 6 seconds. After that, a small turbofan takes over, sipping jet fuel, holding roughly 550 miles per hour for as long as the tanks allow. What's left flying is around 18 feet of airframe carrying a blast fragmentation warhead, low, at about 100 feet above the water. That altitude matters more than speed. Radar beams travel in straight lines. The Earth curves away beneath them. Anything skimming the surface stays hidden behind that curve until it's roughly 25 miles from a coastal antenna. At missile speed, barely 2.5 minutes of warning. And the sea adds its own deception. A radar beam striking a low target also bounces off the surrounding waves, returning 2 overlapping echoes. Sorting the missile from its own reflection, in choppy water, is like aiming at a bird by tracking its reflection in a pond, with wind on the pond. It's why sea-skimming missiles have troubled navies since the Falklands War, and why coastal defenders often get only minutes, not hours. The route. 10 missiles form a loose line toward the coastal battery. 2 peel away on a longer path, toward a second, mobile target photographed hours earlier by reconnaissance. That photograph is already out of date. A mobile launcher can move the moment it starts its engines, and by the time the missiles arrive, the position may be empty. Modern cruise missiles aren't just guided, they're driven. Routes are plotted turn by turn before launch, threaded around known defenses, with onboard cameras matching the terrain against preloaded imagery in the final approach. The one gun that shows up. On the ridge, most of the battery's actual firepower is still cold. Radars have to warm up, launchers have to be slewed into position, crews have to reach their seats. None of that fits inside 2.5 minutes. Only one weapon is already manned. An aging twin-barreled anti-aircraft gun, a Soviet design from 1960, towed behind a truck. Against a subsonic cruise missile, the arithmetic is brutal. By the time a tracer round reaches the missile's position, the missile has already moved a quarter mile. The gunner fires anyway, walking his stream of tracers behind a target he can't catch. 90 seconds later, the missiles arrive. One shears off the radar mast. Others strike the launch vehicles and the reload site, where the battery's own stored rounds begin igniting each other. A 1,000-pound blast fragmentation warhead doesn't need to punch through armor plating. There isn't any. Sheet metal, cable, a radar dish, rubber tires. The site that survived 4 days of prior strikes stops functioning in under 2 minutes. The Watcher. The mobile launcher, meanwhile, has already moved. Trucks folded, engines started, driven off before the strike ever landed. It's the oldest trick in mobile air defense. Shoot and scoot. But something has been watching. An MQ-4C Triton, a long-endurance maritime surveillance drone with wings longer than a 737's, has been holding an orbit over the strait for hours, its radar sweeping a vast stretch of ocean and coastline continuously. That orbit carries real risk. In June 2019, Iran's third Khordad air defense system shot down a U.S. Navy RQ-4A Global Hawk drone in the same strait. Still one of the costliest drone losses in American history. The crew flying the Triton, sitting in a control station half a world away, knows that history and holds position anyway. The drone doesn't need to spot the trucks themselves. Trees and netting can hide vehicles. What can't be hidden is the shape 5 vehicles form when spaced correctly for a working air defense battery. Enough separation that one hit doesn't take out the others, enough clearance for the radar's field of view. That geometry is the same everywhere on Earth, because the physics is the same everywhere. The duel. Coordinates relay up to satellite and back down to the 2 inbound missiles. Modern Tomahawks, the Block V variant, carry a 2-way satellite data link, letting a human retarget them mid-flight, right up until fuel runs too low to permit another course change. One missile turns in low and direct. The other, forced onto a longer, fuel-limited path, crosses over the island itself. The battery gets one chance to respond. A third Khordad system fires a Sayyad-2 interceptor, genuinely one of the harder shots in modern air defense, since it means separating a sea-skimming missile from ocean clutter using a narrow, late-activating seeker. It works. The first Tomahawk comes apart over the water. But guiding that single intercept means the battery's own radar has to stare continuously toward the sea for close to 2 minutes. It never swings inland in time to catch the second missile, now crossing low over rooftops and ridgelines on the far side of the island. That missile reaches the battery's radar and command vehicle and destroys it where it stands. 2 launcher trucks survive, untouched, tubes still loaded. But a battery is a chain, several trucks that fire, and 1 truck that sees and thinks. Destroy the launchers, and steel gets replaced. Destroy the vehicle that sees, and every missile still in its tube becomes exactly what it looks like, a length of pipe on wheels. The trucks can hide again tomorrow. What they're hiding from won't be looking for them the same way twice.
For the fakeness, if you wanna play tough and wanna hate